Preparing to leave.
Yes, yes. Now it's live.
Yeah.
Now it's showing meet is streaming on the live in the YouTube.
Yeah, I can see you all now.
Now there is an option called share screen. Can you see that?
Yeah. Bottom
Just click
green.
on it. Just click on it. Everything will be fine.
Yeah, I have clicked. And then should I open my this thing? Presentation?
Yeah, you just click on the presentation.
Okay. And then again share.
And share. And share. Click on this PowerPoint, then share. Yeah, it's coming.
Yeah.
Now it's perfect. You just do the share screen, this full screen only. PowerPoint show.
Yeah. At that time I'll put it full screen.
Now it's perfect. Thank you.
Shall I leave it like this?
No. I will stop the screen sharing. You just download it.
Yeah. Okay.
Okay. And share. Click on this PowerPoint, then share. Yeah, it's coming.
Yeah.
Now it's perfect. Share screen, this full screen only. Good evening. Don't worry. I'm just getting in. Now it's perfect. Thank you. Shall I leave it like this? No. I will stop the screen sharing. Just download. Yeah. Okay.
Hello.
Hello, Dr. Suresh.
Hello. Yeah.
How are you?
Good evening, sir. Good evening.
Good evening. Good evening. I don't know. Long ago, I have met you somewhere.
Yeah. We met. Yes.
Yeah. Where was it? I don't recollect.
I think in some meeting we met.
Yeah.
Dr. Joseph, you are able to hear me?
Yes, sir.
Hello.
Good evening, sir. Suresh sir, good evening.
Good evening, sir. Good evening.
Hello, Dr. Chandrajiran. Good evening.
Dr. Chandrachudan. Good evening.
Good evening. Good evening.
Yes, sir, I can.
Joseph sir, I am just moving out.
Good evening, sir. Good evening.
5 minutes, wait. 5 minutes.
I have another meeting, sir. That's why.
Sir, admit it.
Yes. I have done everything perfectly. Then now we can manage it. No issues.
Yes, sir, I can. Admit it.
എന്തോ എല്ലാവരും അഡ്മിറ്റ് ആയിട്ടുണ്ട്. ഇനിയിപ്പം മീറ്റിംഗ് ഇതൊന്നുമില്ല. Can do it, no issues.
ഏത് കാണുന്നില്ല, വെയിറ്റ് ചെയ്യണമെന്നുള്ള അറിയാൻ.
I have done everything perfectly. Then now we can manage it. No issues.
ആരെയും വന്നാലേ അഡ്മിറ്റ് ചെയ്യാൻ ഇപ്പൊ എന്താണ്? അഡ്മിറ്റ് കാണുന്നില്ല എനിക്ക്. പോയി ഹോസ്റ്റ് ചെയ്യാനാണോ അലക്സേ? അലക്സേ ഹോസ്റ്റ് ചെയ്യാനാണോ?
എന്തോ
ഹോസ്റ്റ് ഞാനല്ലേ? ഹോസ്റ്റ് ഞാനല്ലേ? അതല്ല ഹോസ്റ്റ് അല്ല ഹോസ്റ്റ് ഞാനല്ലേ നിൽക്കാൻ വെയിറ്റ് ചെയ്യണമെന്നുള്ള അറിയാൻ. ആരെയും വന്നാലേ അഡ്മിറ്റ് ചെയ്യാൻ ഇപ്പൊ എന്താണ്? അഡ്മിറ്റ് ഹോസ്റ്റ് ചെയ്യാനാണോ അലക്സേ? ഹോസ്റ്റ് ഞാനല്ലേ? ഹോസ്റ്റ് ഞാനല്ലേ? അതല്ല ഹോസ്റ്റ് ഞാനല്ലേ? ഗുഡ് ഈവനിങ് സാർ.
Good evening. Good evening.
Good evening. Good evening. Chandrachudan.
അതെ ഒരു കാര്യം ചെയ്യാം. നമുക്ക് ഹോസ്റ്റ് ഞാനല്ലേ?
Dr. Nair.
Good evening, Dr. Nair.
Good evening, good
Good
evening.
evening,
How
Dr.
are
Nair.
you?
Good evening, Dr. Nair, and good evening.
Good evening.
അവിടെ കിട്ടുന്നുണ്ടോ? എവിടെ? ആ, ഉം. ആ, ഉം.
Project
Good evening, Dr. Suresh. Good evening.
Good evening, sir. Good evening. So how are you?
Just fine. It's rainy day here nowadays.
Yeah. No, today Trivandrum is not having any rain. Yes,
Yeah,
since
yeah. Bombay for last 4 or 5 days, almost daily raining.
yeah. And
Like
it is
Kerala climate.
it is very difficult life in Mumbai.
Because of COVID, we are at home, so that is one blessing in disguise.
Yeah.
Dr. Suresh, you are in Trivandrum, staying in
Yes,
Trivandrum.
I'm Trivandrum. Yes.
Which part of Trivandrum?
This is very near to Fort. That means that is Manakad area.
Ah,
This was a containment zone, in fact,
yeah.
in all this area. Now, since last 1 week, we are free.
Oh, yeah. വേണ്ട വേണ്ട മറ്റേ ആ ലിങ്കില് I think most of the people will get in at the last 5 minutes.
Yeah,
Now there are 20.
this time it is Friday.
Ah,
People may be looking for Saturday, possible. But it is publicized. Last time also we told.
Dr. Chandrachudan, BRC is working in full swing or it is?
BRC, I think some 30% people requested.
Yeah.
Otherwise, they were all working from home, and those who are in the Anusat Nagar, they were going inside.
Okay.
And the continuous plans were running anyway.
Okay.
The huge population were to come from all way.
Yeah.
And all the centralized AC facility and all, that is not desirable for this.
Yeah.
So, yeah. I
But
don't know
there
how
are certain things which have to go on continuously. So you have to.
Yeah. Somehow I was feeling during COVID, all our national labs should have worked full swing. Because that is the time BRC also, their biosciences group did some work on this COVID. There are some publications also, but at some point it was not continued.
Sir, good evening. Chanchuran, sir.
Good evening, good evening. How are you?
Fine, sir.
Nice.
Sir. Good.
Good evening.
Good evening.
Yes, sir.
Good evening, sir.
Joseph, sir, namaskar. So, how is situation, sir?
Here better. Kerala, no problem. Kerala, everything is under control now. No plates.
Yes, sir. 2-3 days situation was.
You know this Dr. Yamna Singh, Dr. Yamna Singh.
Yes, sir.
Dr. Yamna Singh, he has written a book on rare earth resources in India. A beautiful book. Dr. Yamna Singh.
Yeah.
Suresh Kumar, can you hear me?
Yes, I can hear you. Dr.
Yamna Singh, he was in AMD earlier, Atomic Mineral Division. He has written a beautiful book
I heard about that. Can you hear me?
Yeah, I can hear you. Yeah.
Yes, sir.
He has written a book on rare earth resources in India. A beautiful book. Dr. Yamuna Singh. Suresh Kumar, can you hear me?
Yes, I can hear. Am I audible?
Yeah.
Okay. Yes, I heard about that thing. So, yes,
അത് ലൈവാണ് ക്ലോസ് ചെയ്തില്ല എന്റെ പോയല്ല ഇവിടെ
Hello, Dr. Yamna Singh.
Yes, sir.
This, Dr. Suresh Kumar.
Yes.
He was former Chief General Manager of IRE.
Yes.
I think he is interested in your book. You authored one book, is it not?
Yes, sir.
Yeah. So
I heard about that. So I'm interested in that thing. So you may give some details about that.
Sir, I will send that link.
Okay.
This is your, sir, email.
Yeah.
This one. It is displayed here. I will send in this, sir.
Okay. Thank you very much.
SURESHIRECH.
SURESH.IREC.
.co.in. Okay, sir. I will send in that, sir.
Okay. Thank you, sir.
Yes, sir. Saran Saab, good evening.
Good evening.
Good evening.
Good evening.
Hello, sir. Good evening.
Hello, good evening.
Good evening, Sharan Saab.
Good evening.
Balram Saab, good evening.
Good evening, Dr. Yamuna Singh.
Good evening, Balram Saab.
Good evening, sir. Good evening.
Saran Saab, good evening.
Good evening, sir. Good evening. Hello, sir.
Hi, sir. Today's speaker.
Good evening.
Good evening. Very good evening.
Good evening, sir.
Good evening.
I am Balram from NGRI, Hyderabad.
I see. Okay. Originally, I was thinking that you are from DAE.
No, yeah, from CSIR.
Okay.
Yeah. Yeah, most of the people in ISAs are from DI, no doubt.
Hello, Nana sir.
Hello, good evening.
Good evening. Good evening.
Good evening. Good evening.
This is really very good. Actually, every evening, I mean, every weekend,
Yeah.
we have this kind of a meeting in this kind of a pandemic situation,
Yes,
extraordinary
yes.
situation in the country, in the whole world.
It's very useful also and enriching also.
Yeah.
Mm.
Youngsters can learn something, and then we
Yes,
also
yes.
learn. Yeah, for learning, there is no age limit. People, every day, I mean, every year, every day is a student.
Yeah, yeah. And we get everything refreshed. Whatever we have already, we know also. That's getting
Yes,
refreshed.
yes.
At least that is that one
refresh,
big advantage.
And the science and technology, various branches, the development is so fast. It's very difficult to cope up with,
Yes.
even within in your own area. Also, it's very
Yes,
difficult
yes,
to
yes,
understand
yes.
what's really going
Yes.
on.
Yeah.
So
And
under
it's
these
very vast.
circumstances, hi sir.
Good evening. Good evening.
Dr.
Good evening,
Chandrachudan.
Chandrachudan sir.
Chandrachudan sir, good evening.
Hi, good evening.
How are you?
Chandrachudan. Good evening.
Good evening.
Welcome, sir.
Yeah, good evening, sir.
Saran, sir.
Good evening. Good evening.
Hi, Dr. Joseph.
Joseph, good evening. Dr. Joseph.
Good evening.
Good evening.
Joseph sir, good evening.
Good evening, sir. Good evening. Good evening.
People are going to YouTube directly. There may be
Yeah, maybe.
Many of them.
Many of them are going to YouTube.
The reason is our usual date is Saturday. Some people might have forgotten.
Yeah. But the reminder has gone to all.
Reminder has gone to all.
That day also, it was told that it will be on 14th. 15th being Independence Day.
Last Saturday.
Yeah. And everywhere reminder has gone. All groups we have put.
Right.
It has come.
Yeah, it's 7 o'clock now.
Yeah.
Yeah, it's 7.
It's better to start, huh?
Hello, Nikrishna Nair.
Hello. Hello.
Bobby sir. Sudha Roy.
Yes, sir.
Anu.
Yes, sir.
Pilla sir. MRA Pilla sir. Next week's resource person. Nair sir, let us.
Yeah.
Good evening, Nair sir.
Good evening.
Nair sir, chairman.
Yes.
Let us start.
Yes. Yeah, please.
Okay. Anu, get ready.
Okay, sir. So good evening all. We welcome you all to the 7th lecture in the ISAS.
Good evening to everybody.
Good evening.
I request Dr. P.V. Joseph, coordinator of this webinar series.
Hello.
To speak now.
Thank you, Anu.
Yes.
President of Webinar Committee, Dr. V.R. Nair, National President of Indian Society of Analytical Scientists, Dr. P.P. Chandrachudan, sir. Chief guest, Dr. Suresh Kumar, sir. Today's research person, Dr. K.N. Nainan, sir. Other ISAs, leaders, members, and my dear participants, good evening to all of you. I am very proud to inform you that ISA webinar is progressing successfully. This is the 7th webinar since we started the series on 4th July. For every webinar, we invite outstanding scientists as speakers. My duty is to welcome you all to this webinar. Before that, I would like to say something about ISAS. ISAS is a professional organization of scientists formed with the objective of disseminating the contribution of analytical scientists to the world. Those who are engaged in R&D, quality control, teaching, and research can join ISAS. More details.
Okay, okay.
www.
No. Okay.
The webinar is chaired by the former national president and the chairman of webinar committee, webinar series, Dr. V.R. Nair. I welcome V.R. Nair to this webinar. Our national president is Dr. P.P. Chandra. He is a former senior scientist from BARC and an expert in total knowledge management. I welcome Dr. P.P. Chandra sir to this webinar. The webinar series is being inaugurated by Dr. S. Suresh Kumar, former Chief General Manager of IRE Limited, IRE India Limited. It is my pleasure to welcome Dr. Suresh Kumar sir to this webinar. Today's resource person, Dr. K, as you know, was the outstanding scientist and deputy director of VSSC. Today, he will talk about Indian Mars Orbiter mission. Sir, we proudly welcome you to this webinar. ISAS recognizes the presence of all the scientists, teachers, and ISAS family members who spared their precious time for attending.
Hello.
We welcome all of you once again. Thank you. Over to.
I'm trying to join.
Thank you, sir. Now I request our chairman of the webinar series, Dr. Nair sir, to speak a few words.
Chandra Chudan, President ISAS, Chief Guest of today's webinar, Dr. S. Suresh Kumar, who is the former Chief General Manager of Indian Railways Limited, Chavara. We have Dr. K. N. Nainan, former Deputy Director, and Deputy Director Vikram Sarabhai Space Center, Thiruvananthapuram. The eminent speaker of today's webinar, Professor P.V. Joseph, Professor Dr. Raghav Saran, members of the EC, and other participants. A good evening to all of you. One of the due to the ongoing uncertainties surrounding COVID-19, ISAS is organizing this webinar series entitled Emerging Technologies and Methodologies in Analytical Science. It was inaugurated on the 4th of July 2020 by Dr. A. Ajay Ghosh, Director of CSIR NIASP Thiruvananthapuram. Already 6 talks are over, and today's talk is the 7th talk in the series. I am extremely happy to see Dr. S. Kumar as chief guest in today's program. We know each other for more than 30 years because I also work in Indian Railways Limited, and we worked together for several years, even though in different units. The topic of today's talk is Indian Mars Orbiter mission, a unique scientific achievement. The Mars Orbiter mission was considered as a technology demonstration project to develop the technologies for designing, planning, management, and operations of an interplanetary mission. It was a prestigious project for not only ESRO but for the whole country. After the launch of this program, our beloved Prime Minister Narendra Modi ji said, "History has been created today. We have dared to reach out into the unknown and have achieved the near impossible." Today's eminent speaker is Dr. K. N. Nainan, who is one of the pioneers in the field of space science and technology in the country, and he was the winner of ISAS Lifetime Achievement Award during 2019. Dr. Nainan is an outstanding scientist who has contributed very significantly to the development of space science and technology in the country, and he is a world-class expert in the above areas, and is well known in the international space scientist community for his outstanding contributions. The pioneering work and technical leadership provided by Dr. Nainan at VSSC has led to the successful development of rocket propellants, polymers, and several chemical systems for current and future missions of ISRO. We in ISAS are proud to have Dr. Naina as today's resource person. Dr. Naina was closely associated with this Mangalyaan project based on his deep knowledge and involvement in the execution of this project. He'll be able to give us first-hand information on various aspects on conception, execution, and outcome of the Mangalyaan project. I am sure that this talk will be informative, interesting, and exciting and stimulating to all of us. I thank all participants once again for their participation and support. Thank you.
Thank you, sir. Now I request our National President, Dr. P.P. Chandrajudan, sir, to make the presidential address.
Dear Dr. V.R. Nair, Dr. S. Suresh Kumar, today's chief guest, Dr. K. Nainan, distinguished speaker of today, Dr. Joseph, members of the EC of ISAS, the galaxy of eminent scientists who are participating in this webinar, and all other scholars who are participating in the seminar. I convey my best wishes from the headquarters of ISAS Bombay. And I also take this opportunity to convey best wishes for a happy Independence Day tomorrow.
Yeah, that's very good.
Today, we have amongst us Dr. S. Suresh Kumar, former Chief General Manager of IREL, a leading consultant in mineral processing engineering, covering many strategic materials development as our chief guest. ISAS thanks Dr. Suresh Kumar for joining us today as the chief guest. Today, we also have a very eminent distinguished speaker, Dr. K. Nainan, who established many significant landmarks, milestones in Indian space program. He established the division of spectroscopy and analytical facilities in ISRO and played a leading role in the development of solid propellant technology. Thanks to Dr. Nainan for joining us today. We all look forward to his excellent talk. Jai Hind. Back to Dr. Anu Gopidath.
Anu. Anu is. I invite Ms. Smita Roy, the head of the Department of Chemistry, UC College, Alua, to introduce. I invite Dr. Suresh Kumar, sir. Sorry. Where is Anu? Anu, just a minute, sir.
Yeah, please come in.
Dr. Joseph, you may invite Suresh Kumar directly. Don't wait for Anu.
Hello, sorry, sir. There was a delay with internet connection. So, as we all know, today's chief guest is Dr. S. Suresh Kumar, former Chief General Manager, Indian Rare Earths Limited, and he will be inaugurating today's webinar. So, with your permission, I will like to give a brief introduction about Dr. S. Suresh Kumar. Dr. Suresh Kumar took his postgraduate degree in chemistry from the University of Jabalpur and doctoral degree in chemistry from the Brampur University. He has worked in various capacities as scientist, technological, and administrator in the organizations like Indian Rare Earths Limited, Department of Atomic Energy, Automotive Research Association of India, and the Vehicle Factory Jabalpur. And some of his former responsibilities include Chief General Manager and Head of Indian Rare Earths Limited, Chavara, Kerala, Head of Corporate Research and Development, IREL, Member Advisory Council of Nuclear Fuel Complex, Department of Atomic Energy, Hyderabad, and Head of Technical Services and R&D, OSCOM, IREL, Orissa. And he was responsible in conceptualizing and commissioning various R&D laboratories and pilot plants in the field of mineral process engineering, hydro and pyrometallurgy, then zirconium-based products, and several other products. And so we are really happy to have you as the chief guest of today's program, sir. And I request you to kindly inaugurate today's webinar and also to deliver the inaugural address.
Thank you, Anu. Respected ISAS National President Dr. P.P. Chandrachudan, Committee Chairman Dr. B.R. Nair, today's Honorable Eminent Speaker Dr. K.N. Nenan, former outstanding scientist and Deputy Director VSSC, Dr. P.V. Joseph, Dr. Smita Roy, Dr. V. Babu, fellow members of ISAS, ladies and gentlemen. Now, it is my proud privilege to be here to inaugurate today's webinar. In fact, I will take 1 or 2 minutes to just to introduce what is my experience with the ISAS since 1980s or beginning of the 81 or so. I was in BRC and for some time, and I learned many things from my seniors working in BRC. So this basically the Indian Chemical Society, this was in fact founded by Dr. P.C. Roy, Sir P.C. Roy in 1928. And we have attended several seminars, conferences in various places in India. And that time it was very, very, what I can say, scientific organization in the chemistry, where so many research work, research papers, industrial work were presented. But later, during the late 70s and 80s, this organization has become unmanageably large. So then the thing is, BRC scientists, few of them thought that why can't we should have an analytical science, because with Indian society, Indian Chemical Society, the importance to the analytical scientists were not that much. And people felt that they should have another organization where the analytical sciences can be given some impetus. And this organization was established in 1983, as earlier it was referred. And then subsequently, most probably this was with Dr. P.K. Jaiswal and Dr. P.K. Padmanabhan as chairman and vice chairman. There were some activities during that period, but it was not that very active. And I remember that when I was in IRERC Chavra in Kollam, a DAE Golden Jubilee Lecture Series 14, the lecture series were organized in 14 January 2004. And there, the then legendaries in the field of chemical sciences were honored. And most of them, I think there were 5 scientists, and most of you may be knowing them as they were the great scientists in their time. Dr. Shankar Das, who was the head of analytical division, Dr. Sundaresan, head of electrochemistry division, Dr. T.K.S. Murthy, director chemical engineering, Dr. C.S.P. Iyer, head analytical chemistry division section, and Dr. T.K. Mukherjee, who was the CMD of IREL, who was the metallurgist. And after that thing, for several years, this organization was dormant. There was no much activity, and the this has been reactivated by Dr. B.R. Nair and Dr. N.K. Pillai. And I think this was the late 2000, if I'm not wrong, 2004 in November or something. And Since then, this ISAS has become a very, very active scientific organization. And now I understand that there are many scientists joined this setup. When we started our career about 50 years back, chemical analysis was a backbone with very limited instrumental backup. Analytical science were evolved with a greater speed, with multidisciplinary adaptability of the chemistry, biochemistry, physics, electronics, optics, advanced mathematics, etc. in later years, maybe later 80s, 90s, etc. And now the thing is, once somebody is a chemistry graduate, chemistry scientist, or physicist, or chemical engineer, there is no difference, because all these things are become when we go to the higher level, we don't find any difference between all these sciences, because everyone has to find the some information and knowledge about the other field. If suppose we are lacking to understand that, then we remain as an analytical scientist, we will not be able to grow further. So this I am just telling to the younger generation, particularly working in the universities and research organizations. And I would like to point out some of those things. Even the UV visual spectrophotometer was not available in many of our reputed organizations, national laboratories. Even in the BRC, that time we were using only Bachmann DU model and carry 11. You know, there the slit width was to be adjusted manually. But now you can see after that thing, Shimadzu, Perkin-Elmer, and so many manufacturers have come. Now nothing is to be, no manual intervention is required. Only you put the solution, you get, whatever fashion you want data, it is available. Now another example, what I feel, I'm request another 1 or 2 minutes may be permitted for little. So I think Dr. Chandrachud and Dr. Nair, you
Please
will
go
have.
ahead.
Hello?
Please go ahead. Very interesting. Please go ahead.
So then the thing is, when we were working on the steel analysis or any other organic this thing, where the carbon and sulfur was to be analyzed, this was only the Strawling apparatus. Manually, we were to take the gas after combustion to be put into the KOH solution and then manually measure how much is the absorption of carbon dioxide. So that was the time, but subsequently, so many advanced equipment like LICO, Rigaco make sophisticated systems have come. Now the manual system has gone and taken backseat. Then the thing is, I remember another major thing what we felt was the alloy that time. This I am telling in 70s, 73, 74, 75, something like that. Stainless steel 304 or 316, where the manganese is 2% and the chromium is about 18%. We were to do by titrating method. And the thing is, 18% chromium and 2% manganese, the color blindness or this yellow color and the manganese color mixes so much, the end point was very, very difficult. And those times, pH meter was also not that very sensitive pH meter. We were having glass electrodes or calomel electrodes. So then the thing is, we were to find out a method where we were to remove some of the chromium by chromyl chloride, evaporating that, and the remaining solution having very low chromium was to be analyzed against the ferrous ammonium sulfate and so and so. So what I'm trying to say is the then analytical chemistry and today's analytical sciences, a vast difference, because now one cannot imagine that how those times people have worked in the system. Now we are having XRF, XRD, X-ray computed tomography, then the infrared spectroscopy, UV visual infra, NIR spectra analysis, mass spectroscopy, EC, and HPLC. Now the thing is the mineral characterization. Those times were only to be done by the microscope. People have to grain count, identify with the optical properties, so on. It was very laborious and very tedious work. But nowadays, the QEM scan has come into the picture. That is quantitative evaluation of minerals by scanning electron microscope. Scanning electron microscope we all are using. But the thing is, that software is more important. The software nowadays gives a lot of information on that thing. So now this is a knowledge based, not the skill based alone. You get the data, but you have to interpret correctly. So your knowledge is very, very important. Now what my request is, the new process developed in the universities, research laboratories, and a number of scientists are working on this thing. It should not be based on the publishing the research paper only. It should be seen when we develop a new process or new thing, we should see that it is how it is to be taken when we are capacity enhancement, the material of construction. Because if suppose nitric acid is there, environmental issues comes, we cannot use nitric acid in industrial big operations. Like sulfuric acid when we are using, then we have to think that dilute sulfuric acid eats away the steel. So lining is required. And if suppose it is a hydrochloric acid, then all the materials are eaten away. So what type of care is to be taken? So process development in chemical aspect is easy, but scaling up is very, very, we thought we should have very much thoughtful. So this is what my point is. I am sorry that I have taken some of your time to explain some of our olden days. Now, I'm coming to my responsibility with your permission to inaugurate the webinar meet of ISIS with a talk of eminent scientist, Dr. K.N. Nainan. I thank the organizers for the opportunity to inaugurate this webinar. Thank you very much.
Thank you, sir. That was a very highly informative talk. So, as we all know, today's speaker is Dr. K.N. Nainan.
Excuse me, one more point. This 2004, this Golden Jubilee, DAE Golden Jubilee, this thing, I have some photographs. I will send it to the organizers. You can keep it in your library. These are the photographs which may not be available in all the places. Now many are scientists, they are not with us. They left this world, but we have photographs like Dr. Shankar Das and all. So I may send it to the organizers.
Thank you. Thank you very much.
Thank you, sir. So we know that today's speaker is Dr. K.N. Nainan, former outstanding scientist and deputy director, VSSR, and Smita Roy, head of the department, chemistry department of UC College, will now introduce the speaker.
Good evening, everyone. It's my pleasure to introduce the speaker of the day, Dr. K.N. Nainan. Dr. K.N. Nainan is a former deputy director of Vikram Sarabhai Space Center and emeritus professor of Indian Institute of Space Science and Technology. Dr. Nainan had his MSc and BSc and MSc in chemistry with first rank and PhD from the University of Kerala. He started his career at VSSC in 1968 as a propellant engineer trainee and retired as outstanding scientist after a tenure of 40 years. He established a state-of-art analytical and spectroscopy division at VSSC, became its first divisional head in 1980, and contributed greatly to the application of analytical sciences for the advancement of India's space program. He played a lead role in developing rocket propellants, polymers, and several chemical systems for ISRO. So, spearheaded several expert teams like a design review team for solid propulsion systems and steering committee for indigenization of space materials. He has guided 28 PhD research scholars and authored 198 publications in international journals and he's having 28 patents to his credit, including one US European patent in the areas of propellants, polymers, and thermal analysis. An honorary fellow of High Energy Material Society of India, fellow of Kerala Academy of Sciences, and a member of International Academy of Astronautics. Awards received by him include a Lifetime Achievement Award of Indian Society of Analytical Scientists in 2019 and Performance Excellence Award of ISRO received from President of India in 2009. With these brief words of introduction, let me invite Narayan sir to handle the session.
Thank you for your nice words of introduction. All of you can hear me, I hope so.
Yeah.
And others may kindly mute their mics. Dr. P.P. Chandrajudan, National President, ISAS. Dr. V.R. Nair, Chairman, Webinar Committee. Dr. P.V. Joseph, the Program Coordinator. Dr. S. Suresh Kumar, today's Chief Guest. Professor C.G. Ramachandran Nair, who is my teacher. I hope he is somewhere here. I saw him. Scientists, technologists, colleagues, friends, ladies and gentlemen. It's my great pleasure and privilege to deliver a talk to such an august audience. And I thank the organizers of ISAS, Dr. Joseph in particular, for this wonderful opportunity. The inaugural lecture of this series was on analytical science in space research, delivered by the renowned nuclear scientist, Dr. A.P. Jayaraman, who dwelt on modern analytical techniques used to explore deep space and distant planets like Mars by NASA, ESA, and Russia. Therefore, I thought it will be very appropriate and interesting to you to know how these instruments are safely taken to Mars or any other planet. It's a great challenge. I want to caution you that the lecture has nothing to do with any analytical chemistry, but on what ISRO has achieved. Can I have the sharing of the slides? Okay. Okay.
Okay, sir.
Is it full screen?
No,
yeah, now it's full screen.
Okay, sir.
Okay, Indian Mars orbiter mission, which happened 2013-14 time frame. 8 years ago, what ISRO has achieved is something about which every Indian can feel proud of. Something which no other country in the world has accomplished in its maiden achievement. That's why I call it as a unique scientific achievement. Now let us see why I classify it as a unique scientific achievement. Because the overall success rate of Mars mission, whether it is flyby, orbiter, or lander, or rover, I suppose I don't have to explain to you what these are, is less than 50% because of the high technological challenges involved in it. If you look at the history of the first attempt to Mars, the situation becomes more clear. See, all the spacefaring nations, including veterans like USSR, all of them have failed without exception in their first attempt to Mars, except India. So India is the only country in the world to succeed in the very first attempt and the only Asian country to reach the Martian orbit. I suppose you can give a big clap. It is not audible, but I believe you are giving a clap. Okay. So today the content of my talk will be answering to three questions: why, how, and what. Why India went to Mars? How our spacecraft, Mangalyaan, meaning Mars craft, Mangal for Mars and Yan for vehicle, Mangalyaan went to Mars. And what are the lessons we learned from India's Mars orbital mission for a wider context, especially for the youngsters and students, and also a couple of slides on the history behind the whole thing. So, why Mars explorations? The global interest on Mars has been there from time immemorial. Romans named it God of War, and Chova Dosham by people of Kerala. I suppose you follow what I mean by that. But then with the advent of telescopes, better understanding came about Mars. Still there were a lot of speculations, like when you see this type of, crevices, people postulated that these are rivers and canals. When I was a young boy, I remember to have every day some news item telling that they have seen somebody moving around Mars, there's a civilization on Mars, etc. But today we have a better understanding of the Mars ever since the space exploration or the Mars missions have started. Well, coming to the special features of Mars, I will not go into all features, but are pertinent to the Mars mission. This shows the satellite image of Mars and Earth. Mars has diameter half of that of Earth and a mass about 10% of the Earth. 1 year is 687 days, and 1 day is almost close to our Earth day. But the challenges are that its average temperature is minus 63 degrees centigrade as against plus 14 for the Earth, and the atmospheric pressure for the Mars is 4.5 millimeter mercury. Even recent analysis has shown, carried out by NASA Curiosity rover, October 12, 2012, has shown that 95% of the Martian atmosphere is carbon dioxide. But the actual challenge for the mission to Mars is none of these, because this can be handled, is the enormous distance and the speed. This part shows the average distance of the orbit from Sun. There is a difference of close to 80 million kilometers on the average of the two orbits, and the speed is this much. So going from Earth to Mars is something like jumping from an aeroplane, moving at a speed of 1 lakh kilometers per hour, to another one moving at... Hello, can you please mute your mic? To another one at 86,000 kilometers per hour at a distance of almost 80 million kilometers. So now coming to the features of Mars, which are linked to this project. One is water on Mars. Mars is very dry. There is no liquid water on its surface. However, there is 26 million cubic kilometers of ice with solid carbon dioxide on the polar region, like this white color, what you see. The hypothesis is that 3 billion years ago, Mars had a denser atmosphere and higher surface temperature and liquid water on the surface, which was a hospitable environment for microbial life. But the more clinching evidence or conclusive evidence of life from Mars would be methane gas in Mars. Why? Because 90% of methane on Earth is produced by microbes. So methane can therefore indicate the presence of microbial life on Mars. Some missions of NASA and ESA shows parts per billion ranges of methane in Martian atmosphere. However, there is no concordant result so far, so this exploration is still continuing. So the question is, Is methane present in Mars as an evidence of life on Mars? Well, the second, therefore, the current global interest in Mars are: one, to confirm the presence of methane or life on Mars. This may hold the key for evolution of life on Earth, because it is postulated that it is these things have a commonality. To establish location, amount, and nature of water present on Mars. To explore rare minerals, because our last lecture by Dr. Ratish said that all the minerals on Earth will be vanishing in another 25 to 50 years of time. Important minerals will be vanishing in 25 to 30, 40 years from now. And the last but not the least is Mars are our future habitat or intermediate station for going to further distant planets, which is a very long-term perspective. Why? Because the greatest scientist of this century advocates settlement of human beings elsewhere because of the disasters like this. I suppose you can read all these things. Stephen Hawking, way back in 2006, postulated the requirement of going to various planets, which is what is happening now. I mean, what will happen now? I should not say it is happening now. But for going to Mars, we have to what you call terraform Mars. See, this is the Mars structure now. We have to convert it into something like this for living. So the original proposal was to use cyanobacterial action, which will take centuries. But then there is, a SpaceX company of the US, its CEO has got better ideas. He proposed a nuke blast over the poles to vaporize, the liberating water vapor and carbon dioxide, which are greenhouse gases, to warm up the planet for a comfortable living and liquid water for there, and oxygen by cracking water and carbon dioxide. So he has, in fact, the SpaceX company has planned a huge settlement on Mars like this. What you see here is a settlement by 2050, for which they are already building. It's a very serious plan, already building a 100-passenger payload spaceship called Starship and a massive rocket called Super Heavy. The combined mass is 5,400 tons and the height is 120 meters, the height of a 40-story building. And the maiden flight is planned in 2022, in another 2 years from now, and a manned flight in 2024. But then in this context, I wanted to show you the picture of one of our beautiful Kerala girls who was actually duped by a company, which is I don't say it was duped. They got broke because a Holland company, Mars One in 2011, was established with a promise to have permanent human settlement on Mars. But then Holland does not have even a small sounding rocket. But they were planning on our modern, the market economy, to buy everything and then including the launch. So 2015, they advertised for volunteers and shortlisted 100 people, which included this girl. So there is a saying in Malayalam, "Aana koduthalum aasha kodukkaruthu." So this is a situation like that. The company is no more there. So our objective for the Mars mission is not for settling in Mars, which may do later on, but the present objective was to develop technologies required for a maiden interplanetary mission. And then there were scientific objectives along with that, which includes exploration of Mars surface and Martian atmosphere using indigenous scientific instruments. So the major elements for the mission are four. that is choice of a suitable launch vehicle from the available ones. So that's why it is given in green. Design and realization of a Mars orbiter, which is new for us. Design of the trajectory to the Mars, which is new, and deep space communication and navigation, which is partially new because we had experience in our Chandrayaan missions. So ISRO has launch vehicles available for launching satellites for what you call sun synchronous polar orbit, 800 kilometers above the Earth, and for the geostationary orbit, which is 36,000 kilometers above the Earth. In launching the geostationary satellites, actually the launch vehicle puts it in what is called a geostationary transfer orbit like this, and then firing the liquid apogee motor, they are taken to the geostationary orbit by the satellite propulsion. Why I told these things is that these are involved in our Mars mission as well. So this shows you a comprehensive picture of all ISRO's launch vehicles. Two smaller ones, even though they are small, they are as heavy as 50 tons. SLV-3 and ASLV, which are the experimental launch vehicles of the 80s. They have the payload capability of only about 50 to 100 kilogram in low Earth orbit, whereas the PSLV, which is the third one, which is highly reliable and cost-effective operational satellite launch vehicle. It has a record of 41 successful launches and 237 foreign satellites from 28 countries, including USA, Britain, France, all those, Japan, all these countries have come to us and launched their satellites using this vehicle. It's very versatile. It is used both for sun synchronous polar orbit with 1.8 tons and geostationary transfer orbit with about 1.4 ton missions. Well, we had what is called GSLV, this one having much higher payload capability of 2.5 ton at that time. However, we didn't choose it because at that time we had 8 flights, out of which 3 were unsuccessful at the time of the choice. But today the situation has changed and it has also become a very reliable vehicle. Today, if we were to go to Mars, we would be using GSLV Mark III, India's most powerful rocket to date. Its mass is 630 tons and a payload capacity of 4 tons in GTO and 10 tons in low Earth orbit. Its first successful flight was here and it was not available at the time of the choice. Okay, we have selected the launch vehicle. Next is design and realization of the Mars orbiter Mangalyaan. It was done by URAO Space Center, that is at Bangalore. The spacecraft is made with autonomous features because of the enormous distance to Mars, because up to 24 minutes are taken for two-way communication, and by then if some mishap occurs, we cannot control it from Earth. So it's an autonomous vehicle. This is its picture, and its total mass is 1,340 kilogram, which is within the payload capability of PSLV, and the propellant mass is 850 kilograms. The propellant used in this rocket are, the oxidizer is what is called MON3, and fuel is monomethyl hydrazine. This was developed in our entity and then at VSSC. MON3 is a mixture of 97% nitric oxide and N2O4 and 3% nitric oxide. N2O4 is prepared by the catalytic oxidation of ammonia, the technology we developed, and it is produced in industry. Nitric oxide is prepared by the reaction of sodium nitrite with nitric acid. I know that chemists will be happy only with a couple of equations. That is why I have intentionally brought this slide into my presentation. Usually it is not there. And we have established a plant also in the beautiful terrain of Mahendragiri near Nagarjuna. Monomethyl hydrazine is prepared by the reaction of excess methylamine with chloramine in presence of alkali. Technology was developed and transferred to industry for production. This is our MMH plant at Tanuku. There are 2 liquid engines in Mangalyaan, which are developed by our liquid propulsion center for the purpose. They are used in our satellites, routinely in our satellites. The main thruster is a 440 Newton liquid apogee motor, which you have seen for raising the orbit. And there are 8 numbers of small thrusters used in attitude, orbit control, and other maneuvering. This is the main thruster, and these 8 are for steering your satellite and Mangalyaan. There are 5 measuring instruments on board Mangalyaan to measure the surface morphology and Martian atmosphere. All were indigenously developed, and the total mass of the all 5 instruments put together is only 14 kilograms. One is a methane sensor, a infrared radiometer, and layman alpha photometer to measure the H2D2 ratio to find out the study of how water was lost from Mars. This is for, the first one is for measuring methane. And then we have a quadruple mass spectrometer for measuring abundance of neutral constants in upper atmosphere, developed by the Space Physics Laboratory of VSSC. A thermal infrared imaging spectrometer for surface composition mineralogy of Mars by our Space Application Center Ahmedabad. And of course, an invariable part of all this type of mission is the color camera. Okay, we have the launch vehicle, we have the spacecraft. Now we have to go. So there are 3 major stages of going to the Mars. First one is to leave the sphere of influence of the Earth, which was done by using PSLV and the spacecraft propulsion, for which we have the Chandrayaan experience. Then getting injected into a predetermined orbit around the sun and cruising to Mars, for which we didn't have any earlier experience. Entry to the Mars orbit, we have a limited experience for lunar orbit insertion. So on November 5, 2013, Mangalyaan was launched by PSLV into a 250 by 23,500 kilometer elliptical orbit around the Earth. This use, I am just giving a comparison, this used for this operation, 260,000 kilograms of the launch vehicle propellant was used. Thereafter, we had 6 orbit raising maneuvers and injection towards Mars by the spacecraft propulsion, for which only 447 kilogram of the spacecraft propellant was used. Why? Because in the first phase of this orbit itself, we have gone beyond the Earth's gravity pull. So I am just showing you a cartoon or a video of how it has gone, how it has performed. Okay. With this last operation, we are entering into the Martian orbit. Okay, you please look at this very carefully, because this trajectory was designed based on thousands of simulations and very precise calculations, because none of this is susceptible for any experimentation. This is the one which was around the Earth. So at this point, which was on November 30, the velocity of the spacecraft was increased tangentially like this. So that is called Hoffman transfer. To take it into an elliptical orbit around the sun. This is sun, this is sun, this is Earth at the time of the launch, and this is Mars at the time of the launch. So it was injected into an orbit round the sun. This is a Mangalyaan orbit. Going around that needs no energy, because it is like a satellite around the sun. That is the crux of doing it at minimum energy. But then the travel from the point 2 to 3, where it met Mars, involved a travel of 667 million kilometers, and it needed 300 days to travel from here to here. At this point, Mars was here. But when our Mangalyaan came here, Mars will be moving to this point. So the calculation, our assumptions, everything has to be very precise. Then only it will be coming to this point. So, but then the calculations and the performance of the propulsion was so precise that only 2 minor orbital corrections were needed, which involved only 0.8 kilogram of propellant utilization in 300 days. Then Mars also arrives at the same point at the same time, and then on September 24, the spacecraft was to be slowed down for the Mars gravity to capture it into its predetermined orbit. If you don't slow it down, it will go again in its orbit. So that is what happened on that day. So this, I'm just trying to show it in a cartoon. This was captured there very precisely. So entry to the Mars orbit. On reaching the sphere of influence of Mars, the velocity of Mangalyaan is to be reduced from its sun orbital velocity of 22.1 kilometer per second to precisely 1.1 kilometer per second to get it captured into a predetermined Martian orbit. The important question at this junction is that, will the engine work? Because the engine was on hibernation for almost 300 days in deep space environment because of its complex geometry with lots of valves and all whatnot. So the answer came from ground simulations and a compatibility test. And most important thing was on T-2 day, we had a 4 seconds firing of the engine, which gave exactly expected results and great confidence in the mission. So the major events on September 24 was early morning, the spacecraft was turned 180 degrees and then fired to reduce its velocity from 22 to 2.1. The thrusters were fired for 24 minutes and 18 seconds using 248 kilogram of the propellant. And the velocity, look at this data. What a fantastic data. The velocity was reduced to 1.099 kilometer per second as against the requirement of 2.00 kilometer per second, within 0.1% of the target. A near perfect performance of the propulsion system, which is a record for any maiden flight by any country in the world. The spacecraft was then turned back to the normal position, and exactly at 8 a.m. we got the confirmation of the orbit from Canberra, where it was sighted first. It was very close to the predicted orbit, and I should call it as a perfect mission, because this is what we predicted, 823 by 80,000 kilometers before the mission started, and this is what we realized. I want to again say that this is a rare feat by any country in the world in its maiden attempt. And only we have more than 50 kg of the propellant left over for more than 1 year of life of the satellite. So this is the first picture of the Mars taken by Mangalyaan, presented to our Prime Minister by the Chief of ISRO. So India has now become the first country in the world to reach Mars orbit in the very first attempt, and the only country in Asia to reach the Mars orbit. And we joined the elite group of 3 spacefaring nations of USA, Russia, and Europe. Some other features. This is the most cost-effective Mars mission ever done on Earth. because our cost was 450 crores, making it the least expensive Mars mission to this date. This is our cost, this is the European, this is American, this is Japanese, and this is the Chinese. Not only that, it was realized in a record time of 15 months. The normal time slot for doing such a mission is 36 months. This was possible because we had our reliable PSLV off the shelf, and also the entire ISRO worked for this goal. This is yet another important point, is that it is performing beyond the mission objective of 6 months in orbit. The mission objective was only 6 months, but on 24th September 2019, Mangalyaan completed 5 years in orbit and has enough propellant to complete another year. This is a standing testimony for its performance, because this is the picture taken by Mangalyaan of the Mars moon on July 1, 2020, and it was released to the public. So it's a glorious example of quick, innovative, and low-cost way of doing major tasks by India. But then this was a New York Times cartoon which appeared immediately after this mission. Indian going with a cow, knocking at the door of the elite space club. There was an uproar in all over India on this cartoon. But to me personally, this was, according to me, it was a very good cartoon. Why I say it was a very good cartoon? Because it tells you that in spite of being backward, we have achieved it. We don't have to be elite by caste, creed, or color to do great things. That is what it means. ISRO itself is a glorious example of this. We had a very humble beginning in 1963. We didn't have even a lab. Our laboratory was a church building, and the parsonage was the place where hazardous operations were conducted. We were the late entrants. All other spacefaring nations ended earlier, and ours was a totally civilian program, whereas all other spacefaring nations had the military support for their program. In spite of this, today we are top in utilizing space technology for societal applications. The Indian National Space System, which is a mature space system comprising of our own satellites, remote sensing, communication, navigation, and scientific satellites, our satellites, our launch vehicles, our own launch facility, our own tracking facility. We are one among the 5 nations in the world having these capabilities, providing nationwide services in communication, weather monitoring, disaster management, education, health, management of natural resources, etc., etc. I don't have the time to go into all the details, but I will give you 2 examples as a typical case. For example, the telemedicine center from Amardanandamayi Institute of Medical Center at Kochi. A doctor sitting here can do the diagnosis of a patient in remote Jammu and Kashmir, or in Assam, or in Andaman and Nicobar. We have 22 similar telemedicine stations. And then we have a program that is called Forecasting Potential Fishing Zone. That is from the color of the sea and also the sea surface temperature. Ever since we introduced that program, there is a 50,000 crore worth of additional catch of the fish because of this program. Well, there are many such like that, but there is nothing comparable to saving of the life. Just to give an example, in 1970, November 12, there was a Ebola cyclone where 5 lakh deaths were reported in India and Bangladesh because there was no satellite facility for forecasting this type of cyclone. But a same or even a higher intensity cyclone called Fani cyclone hit our coast on 2019 May 2. The death was only 89. This was due 68. Sorry, due to the timely warning and evacuation of the people based on pinpoint accuracy of the cyclone prediction. Well, friends, ladies and gentlemen, this is the realization of the vision of Dr. Vikram Sarabhai. This is Dr. Vikram Sarabhai, who, like a prophet in 1967, he declared in Geneva that we must be second to none in application of advanced technologies to the real problems of man and society. Well, it was a prophetic statement because today India is second to none in application of space technology to the problems of man and society. Well, this is one of my prized possession, this picture, because it was taken when he came. Dr. Sarabhai came to inaugurate the instrumental analysis lab in 1971. I was given the task of building up the lab at that time by my boss, who is here, Dr. Vasant Govarikar. Dr. Sarabhai, whose birthday, 101st birthday, was day for yesterday, 12th of August. I pay a big salute to the great visionary leader of Indian space program. So he became, as you know, director of physical research PRL at the age of 18. Sorry, at the age of 28. And therefore, he was always happy to get associated with youngsters. I was 24 at that time, so both of us are in good smile. And I was, of course, a handsome boy at that time. I hope you will agree, with a lot of hair on my head. Well, Dr. Govarikar, under Dr. Govarikar, we started the R&D, research and development of propellants and chemical systems for Indian space program in a very small asbestos building. And this was our laboratory at that time in a corridor. But from there, what we are today, because Sarabhai vision became a reality through the vitality, the hard work with passion and perseverance, not deterred by failures of those who followed, the values of ISRO, about which I will tell you in the next slide. Professor Satish Sawant followed him, and he succeeded Dr. Sarabhai. He materialized Sarabhai's vision and built ISRO into a world-class organization. He channelized efforts of the entire ISRO community towards realizing a common goal to meet the national needs. He involved Indian industries and academia to realize the goals. But despite these best efforts, we had failures. One of the most disappointing failure in the history of India's scientific world was the failure of our first launch vehicle, SLV-3, 1971. This was Professor Dhawan going with he was not doctor at that time, Mr. Kalam, who was the project director for this SLV-3 being taken to the launch station. Unfortunately, it was a failure. But then he gave us the confidence to overcome the failure. He told us we have stumbled but not fallen free. He gave the people the credit of success. You would have read it in Wings of Fire. To Prime Minister, Dr. Kalam was presenting and he was in the background. Whereas when the presentation was to be made to the press after the failure, it was Professor Dhawan who was in the front and Kalam was in the back. That is what we call by ISRO culture. ISRO searches for what caused the failure and not who caused the failure. The community owns the failure and finds the solution. We have very strong failure analysis teams, and I myself was chairing one such team for almost 10 years. So that is what transformed this gentleman to this gentleman, the first citizen of the country. Otherwise, he would have been disappointed all through his life. He has told this particular quote. I don't have to read it to you. Well, not only I myself stand testimony to the conducive atmosphere of freedom, encouragement, and faith in Indian youth. See, I mean, let me take a minute to explain this old picture. There was a failure of the static test of the first stage of SLV3 sometime in 1976 or 77. The nozzle failed. The project was in very forefront of realization. So the general consensus in the review committee was to take it to France for the thermophysical property evaluation. Then I stood up from the audience of 100, raised my hand, and Professor Dhawan, who is here, asked me, yes, what do you want? I said, sir, there is no need of sending it abroad. Give me 3 weeks, I will do it. We have done it in our laboratory, I should say successfully, and Professor Dhawan, along with Dr. Govarikar, examining that particular results, what we have done. Ever since that, we never had a failure of the composite nozzle. So the vision, vitality, and value have become the hallmark of ISRO in all areas of our work. For example, this is Dr. Govarikar explaining to Prime Minister Indira Gandhi a proposal to set up a huge pilot plant while we were struggling to make a tiny rocket like this. You know, this was our status in 1960. This is a tiny rocket. The same operation now being carried out on this. This is a 200-ton solid motor, the 3rd largest in the world. So this is yet another great pioneer in the work, Mr. M.R. Kurup, who was handling on liquid propellants. I was fortunate to work with him subsequently with him. This is how we used to hand over the liquid propellant to U.R. Rao, who was a satellite project director. Oh, somebody is trying his or her skill of drawing. I don't know. In my this thing is it is. Please refrain from doing so. Okay, but today we are in this position. Yeah, a state-of-art plan for producing this. Not only that, we had a technology denial for the cryogenic technology from Russians under the pressure of the Americans. And at that time, we took it up in ISRO as a great challenge, and 40 special chemicals and polymers were indigenized in our group for the cryogenic program. So I would conclude 45 minutes, which has been allotted to me, the lessons learned from ISRO's successful mission. My dear friends, if you have a dream for life, if you have the confidence to achieve it, if you have the passion and perseverance to realize your dream with hard work, and if you are not defeated by setbacks, and if you learn from failures and improve upon, if you hold values in your life, you will succeed in your endeavor. Vision, vitality, and values are the 3 V's to ensure the V of victory in your life, my dear friends. So yes, we can. From our experience, yes, I say yes, we can. And I say yes, we did. Now at this age, looking back for the 50-odd years, I say yes, we did. Why I say yes, we did? This was the scenario when we started. Abdul Kalam, along with one of his colleagues, there was no laboratory chair, no table. So starting on the earth, assembling the payload, being carried on a bicycle to the launch tower. This was the size of our rocket, 6 kilograms in February 1969, when the man landed on moon. But today, this is the size of our rocket. A increase in rocketry by 100,000 times. Not only that, in performance, these two S200 motors, the S200 solid motor produce 500 kilonewton thrust, which is the thrust of 22 giant the state-of-the-art Boeing jet engines, the biggest ever Boeing jet engines firing together. Yes, friends. So let me wish you, all of you, to say yes we can in your life, and at my age to say yes we did in my lifetime. Thank you very much for your nice hearing. That's all. Over to Joseph.
Thank you, sir. So now this is open for discussion. So if the participants are, if they want to ask something, it's open for discussion.
Dr. Menon, I am Chandrachudan here.
Yeah.
ISIS also takes pride in paying rich tribute to Dr. Sarabhai, Dr. Gavarikar, Dr. Dhawan, and Dr. Abdul Kalam. And kudos to you, and ISRO colleagues for a great Mangalyaan full of vision, vitality, value, leading to a magnificent victory. We, all of us, really enjoyed your great informative talk, and thank you for taking us through a spacewalk into Mars. So we are all really proud of you and your ISRO colleagues, and it is indeed a very befitting talk on the eve of India's Independence Day tomorrow. Thank you very much.
Okay, thank you.
Thank you, sir.
Okay.
Sir, good evening, sir. I am Sriman Narayanan from Chennai.
Yeah.
It was a wonderful talk, sir. Really, we are very thankful to you, even though we are somewhat educated. We didn't know exactly what was going in ISRO and how hardly you have worked from scratch to this level, sir. And when you were talking about the propellants, is there only one type of propellant that is being used or any alternative propellants or mixtures have also been tried out?
Yeah.
So that is the first question, sir. And the second question is whether these type of propellants can replace the fuels that are being used for aircrafts now, for planes and other things.
I think it's a very good question. Let me answer to you. There are two types of propellants. One is called solid propellant and another one is called liquid propellant, and a third variety is a hybrid propellant. That means a combination of these two. We use both of them in our launch vehicles, solid propellants, which are developed in my laboratory, and liquid propellants, which in my area I have shown you how they are made. So these propellants are chosen for different missions for different requirements. For example, you want to have a large thrust to take off from a huge weight to just to take off from the earth. We use one type of a propellant. Usually it's a solid propellant or a semi-cryogenic propellant. Whereas if you have got very high impulse to be delivered in the last stage to put it in the orbital velocity, then we use another type of propellant called the cryogenic propellant, which is liquid hydrogen and liquid oxygen. It's a very, very specialized subject. That's what I was telling you about the embargo by Russians. They promised the technology transfer, but they withdrew from the promise by the pressure of the Americans. But then we developed. It took 8 years for us to develop. And what they denied us was a 8 kilonewton type of a thruster. But what we have developed is CE20, which is 3 times more powerful than that which is used in our Mark III. So there are a gamut of different types of propellants which is used for different missions. It depends on the cost, the thrust to be developed, the impulse to be delivered, and also the ease of handling and so on and so forth. But the basic difference between a propellant and the aircraft fuel is a propellant is a mix of both fuel and the oxidizer. because the propellant has to work beyond the Earth's atmosphere and also sometimes underwater. So it contains both oxidizer and fuel. What I have shown you as MON3 was the oxidizer and MMH was the fuel for this particular mission. But aircraft uses only the fuel, which is a hydrocarbon fuel. What we use is a higher energy type of fuel, but there is a specific propellant called semi-cryogenic propellant in which we use hydrocarbon fuel also, which is used in very big, that large thruster which I have shown you, which the Americans are planning to send it to the Mars. It uses the hydrocarbon fuel because it is very cheap in price. So I think it's a good question. I hope I have answered your requirements.
Thank you, sir. Thank you very much.
Okay.
I am Chandrajudan once again.
Yeah.
I have a question, rather a feasibility. Is there any scope of evolving ISRO system to accurately predict the rainfall? I ask this question as because it provides a useful impact in management of floods, which has become a very an annual event in many parts of our country.
It's a combined effort of ISRO and IMD. ISRO predicts where our satellites predicts the formation of huge clouds which are over the sea. But then, as you know, the final moment, see, there is a prediction when it moves also. In the final moment, when there is, you see, the climate system is so complex, especially near the equator. If there is a minor variation or gradation in temperature, the wind direction changes and therefore it goes from one end to the other. That is why it's on tropical country, the predictions are somewhat different. But today we have got very good prediction methodology. Why? Because even a week ahead or 2 weeks ahead, we know where the huge cloud formations are there. So there is no uncertainty or difficulty in predicting major rains. However, there are what is called the summer rain, which comes out of localized vaporization and then condensation. Those are more difficult to predict and they are more frequent in countries, tropical countries. So this is a complex function of vaporization, the temperature gradient, the velocity of wind velocity, and also various other factors. So ISRO has played a major role in today, predicting the movement of the large clouds, which you see almost in our earlier in Doordarshan and today in your everyday site. Okay.
I asked that question specifically when I came across some amateurs, individual level, somebody in Chennai, somebody in Cochin, they are able to, based on their conventional information, reasonably accurately predict the rainfall at individual level. So it is that is all amateur prediction.
So my grandma also used to predict. If she look at the sky, and if there is if she says that there is a dark cloud on the north on the east, then she will say, okay, today it will rain, and it invariably happens. But these are very short-term predictions. You can see and then say predict it. But then what is involved is over a whole country, or the whole continent, or the whole world, how the rain will be, it will be very difficult to predict without satellite support data. That is what I was trying.
Thanks for a very marvelous talk. Thank you very much.
Okay. I am Unikshan Nair.
Yeah. My old friend.
Sorry, sir. It's a very good talk, very informative and very good talk. And as far as Chandrajudan asked, prediction satellites are also there. But there is one more thing I think you may have forgotten, MST radar.
Yeah.
MST radar put up by the VSSC at near Tirupati. That is also giving information on the atmospheric changes. That is one important thing that you have to remember. So they are doing it very well, and that is why this year all the cyclones, when they are born, it is informed. They were informing us that rain will be more because of that such and such cyclones. That is very accurately predicted this year. That is a one achievement because of the ISRO. Then another thing I want to appreciate ISRO, they have included the industries for production of the different components. When I told this to somebody, they were all surprised because industries contribute a major share, a good share in the development of all these things. That technology is developed in ISRO and they are making the thing and making it available to the industry. That is also another thing. I think Dr. Nainan also said that.
Yeah, thank you. Thank you, Dr. Unikrishnan Nair, who is my close associate and friend, for reminding me about our MST radars. I was all the while, my mind was stuck upon the satellites. That's why I left the MST radar. He himself has done a lot of work on these radars and then predictions. What Unikrishnan Nair said was yet another thing which I think I mentioned to you is that it is ISRO's philosophy that once we develop a technology, we transfer it to industries for production. That is, except solid propulsion technology, because solid propulsion is a very highly classified technology and it's also a very dangerous technology. Almost all chemical technology, the manufacturing, the fabrication, hardware, all these things have been transferred to industry. And we have also very good tie-up with academic institutions and also the R&D institutions for realizing our materials. Thank you, Dr. Unikrishnan Nair.
Thank you.
Thank you, Dr. Unikrishnan Nair. It's basically the DIE culture and ISRO culture very much synchronized. Thank you very much.
Thank you.
Yes, so if we don't have any doubts, I think Dr. Joseph can just brief us about the next talk in the webinar series.
Thank you. Today's talk is different from all the other 6 talks. Dr. Nainan illustrated the uniqueness of Indian Mars mission. He narrated the hard work, determination, and the perseverance. Kudos to Dr. Nainan, sir. The next Saturday, that is on 22nd August, Dr. M.R.A. Pilla, former head of Radio Pharmaceuticals Division, BARC, will deliver a talk on the emerging trends in the application of nuclear medicine in the diagnosis and treatment of several diseases, including cancer. We invite you, all of you, to the next webinar. One more notice to you. The link for feedback is given in the chat. You can use that for your certificate. Thank you. Over to MC.
Okay, sir. Thank you, sir. Now I request Dr. Babu, Manager R&D Division, HIL, to express the vote of thanks.
Good evening, everybody. Today, we are all thrilled by a wonderful speech by Dr. K.N. Nainan sir, former outstanding scientist and Deputy Director of VSSC. In behalf of ISAS, I express my thanks for your outstanding and informative speech, sir. I express my thanks to Dr. V.R. Nair, my ISAS chief also, the coordinator of this German, for conducting a wonderful program here. I again express our national president and our guru, that is Dr. Chandra Student sir, for organizing a good program for all the people. I express Dr. S. Suresh Kumar, former Chief General Manager IRE, for inaugurating this program. I express my thanks to Dr. Smita Roy, HOD, Department of Chemicals, UC College, Alva. And also I express my thanks to my friend, Dr. Anu Gomidath, for for every program conducting this program. I express my thanks to all the participants who attended this seminar. Finally, I express thanks to my friend, Dr. P.V. Joseph, who is the backbone of our program. Thank you. Good night.
Thank you.
Thank you.
So thank you all. We'll meet on next Saturday.
Thank you. Thank you very much.
Good night. Good night.
Good night, sir.
Good night.
Hello, sir. Good morning. Good night. Good night.
Good night. Good night. Good night. Good night.
Masu, sir.
Good
Nainan, sir.
night.
Good night.
Good night.
Sridhar Boja. Good night. Good, sir.
Good night, sir. Good night. I'm Sridhar Boja from IICT Hyderabad. Yeah, I have met Nainan sir in IICT. I know him. Yeah. Hello, sir. How are you, sir?
Fine, fine. Thank you. Nice.
Great,
to see you
great. It was a very wonderful talk, and I've heard. I have close associate with you, so I enjoyed your talk.
Yeah, I remember very well. It was about 15 years ago.
Yeah. Chaudhary sir, Lakshmi Kanta madam, and all.
Yeah.
Thank you. Good night, Dr. Nainan and Dr. Suresh Kumar. Good night.
Dr. Suresh Kumar, sir. Thank you, sir.
Dr. Suresh
Very
Kumar.
nice, Joseph sir.
Thank you, sir. Thank you, sir.
Yeah. Please continue like this.
Thank you, sir.
Okay, sir. Bye.
Okay. Bye.
Dr. Joseph, Dr. Nair.
Not Friday, Saturday, 7 p.m.
Okay, good night. Good night, Dr. Joseph.
Good night.
Dr. Nair, good night.
Good night. Good night.
Good night, sir.
Babu.
Yes.
Babu.
Okay. I'll talk to you later. Okay, sir. Very good. It's a good program.
Okay, Joseph. So I will say good night to you. I was staying back to see if anybody has got anything to ask of the cup. Then I will remain for a while. Okay, now most of the people have left.
A mischievous student has been doing some mischievous.
Yeah, some kids must be doing something. Okay. Okay then. Okay, Joseph.